So in problem 10.1, we're given the components of a stress tensor at a certain point in matrix form, and we're asked to both determine the principal stresses and the principal directions. So as we solve for the principal stresses, we use equation 10.1, I believe, here, which just gives us the base form for an eigenvalue matrix. So we write out that matrix here just for reference later. Then we can take the determinant of that matrix to solve for our roots or our eigenvalues. Do that, do a little bit of algebra, and we get these as our eigenvalues. And those are our principal stresses as well. So the next step is to determine the principal directions. So for each of the principal values that we get, we're going to plug those in for lambda in the matrix. And each line of the matrix we can turn into its own equation. So we have three unknowns in each case, so we need three equations. So we make those three equations from each row in the matrix. We can rearrange and solve for each one. In this case, for my initial value, I just stuck to one. So once I got to a point where I had to decide which variable to give an initial value, I just picked one. So for our eigenvalue of -3, I just picked x2 equal to 1, and then I can solve for x1 and x3. And then we get our vector here. Oops. So normally, I guess if you had good etiquette, you would normalize that vector, but I was too lazy to, so I just left it in that form. But we just repeat that same process for the second two, or last two eigenvalues, and then we get our vectors for those and the principal directions for those. 10.2 is pretty much the same thing, just instead of a matrix that we're given initially, we're given a tensor equation for sigma here. So all I did was just expand out that equation that we were given, and you get this. And it's a little easier to see how to build a matrix out of it. So basically, I just looked at our unit vectors in each term in that equation, and then just recognized that in this case here, we have E1, E2. So E1 corresponds to row 1, and then E2 corresponds to column 2. So I know that row 1, column 2 is going to be tau cosine theta. And then I just do that for the other three terms we have here, and I build my matrix. So once we get that matrix, we can then find the determinant to eventually find our eigenvalues. So we do that, take the determinant, expand out all this algebraic nonsense, and then we get our eigenvalues. So part B asks us to determine the principal directions. Again, we're just going to plug in each of our eigenvalues into the matrix for sigma. So we do that here. Three equations pop out, and then by strategically picking our initial value for one of the variables, in this case, again, I just stuck with one. It's just simple. We get our first vector, or first principal direction, I suppose. And again, proper etiquette would be to normalize it, but I didn't do that. So we just repeat that process again for the eigenvalues 0 and tau, and we get our other principal directions.